on the table is in or at rest, so it means it's not moving. And then it says S is in equilibrium, meaning it's also not moving. So the whole system is at rest. Okay. Now it asks there, find the term static frictional force. Tatu. Mooi. Then 3.2, what is normal force, Rory? Yes. Okay, I've already told you at least 30% of your question paper is definitions. So go study your definitions. All right, there is about at least one, maybe two definitions per question. So that's 4 marks per question that you know is theory. All right, then question 3.3. I asked Roy a free body diagram of all the forces acting on Q. And then they say the length of your arrows must be this, corresponding with the size of the forces. And it counts 7 marks. Now there's definitely not 7 forces. Okay, those 7 marks kind of goes for the size of your arrows as well. Khali, what are the forces acting on Q? Okay, more? Ignore him. Yes? Tension force. Okay. So there is 4 marks there for the 4 forces. And then the other marks went for the fact that I could see that these 2 are more or less the same size. And these 2 are more or less the same size. Why? Because the object is not moving. Alright. Now they didn't ask it, but you are definitely going to do it. You are going to draw the diagrams for knot S. For the knot at S. Okay, there you're going to have gravitational force towards the center of the earth, tension, I think we call it T2 there, and this one is T1. Okay, that gravitational force is for the gravity of P, the block P pulling it down. Right, now how did I know I have to draw a diagram for S as well? Because if I see tension there, I know there must be tension in another object that it's connecting. The rope is connecting 2 things. So I think they go, this goes T1. So if there's a T1, there must be another T1 somewhere. Okay, and that's how I knew I had to draw for knot S. Then you see this is at a weird angle. So you're going to split it up into its perpendicular components, the X and the Y components. If you didn't do it, are you doing it now? No, Khali, where is your book? Where is Khali's book? Khali, who has your book? I'm going to lose it if he's not writing in his book. So just give him his book. Who has it? Wow, and whose book are you writing? Who did you give your book to? Because you're going to go out of my class now. You have 10 seconds to find it or you're out. 10, 9, 8, 7, 6, 5, 4, 3, 2, okay, out. You can see I take this work seriously because this is grade 12 work. I go through it step by step. If you can't even do that, at home by yourself, then you shouldn't be in class. Right. Now you're going to highlight. The forces are in the same plane. We highlight the same color. Okay, yes. Fg of P. So we drew the forces on S and the weight P is pulling it down. So it's the weight Fg of P. Alright. Then we've already figured out on the left hand side that these forces should be equal to one another. Why? Two reasons why. Number one, the object is not moving. Number two, there's only two forces. So then they must be the same. If there were three forces, like that, then the two things on the right would be equal to the two things on the left. Okay, since there's only two, they will equal to each other. Same here, the object is not moving up or down, and there's only two forces, so then they are equal to one another. Okay, if we look at S, then again, this knot, they say, is at rest, it's stationary, it's not moving. Okay, so again, these two things must be the same size, and these two things must be the same size. Why? Because at rest, not moving, and there's two yellow forces here, and there's two purple forces here. Are you with me? Okay. Right, now the next question they ask, 3.4. What is the size of the horizontal component of the force that T2 exerts on knot S? So they ask you, what is this one here? Okay. Now it counts only one mark. One mark tells you it's just an answer. So it should be there, right there in front of you. Okay, so now we look. They gave us this angle to be 34.98. That's all they gave regarding what's ever happening here. But what color did I highlight it? It highlighted yellow. This one is yellow. And we just said they must be the same size. Do we have T1? No. Okay, let's check. Here I have T1. And this one is the same size as this one. And they gave me this to be 171.5 newtons. So because this one is equal to this one, this is 171.5 newtons. Because it's the same rope, this one is 171.5 newtons. And because this object is not moving, and because there's only two forces, T1 is equal to X. So X is thus 171.5 newtons. Yes? No, you can just say horizontal component or whatever. Alright, so the reason why most of you could not do this question is because you didn't draw the diagram. Ne? I have said this over and over again. Even if they don't ask it, you draw the diagrams. You highlight them. You split them into their components. It's very important that you do it. Okay. Then question 3.5, they ask, what is the size of the vertical component, that one there, if the angle is 34.98? Okay, so now we have, in that triangle, this is 34.98 degrees. This X here is 171.5. We've just calculated that. And they want to know what is Y. Courtney, how are you going to calculate Y? You have this angle, you want opposite, and you have adjacent. Tan. The tan of theta is y over x, so opposite over adjacent. So the tan of 34.98 is y over 171.5. How? 119.996. So what is it? 120 newtons. Okay, so we got this now to be 120. Now they ask at question 3.6, what is the size of the weight of block P? Again, 1 mark, so it should be right in front of you. Where is the size of the weight of block P? There is it. I highlighted purple. What else is purple? This one. They must be equal to one another. Why? Because the object is at rest and there's only 2 forces. So this one must be the same size as that one, which is 120. So that is why Fg is 120 newtons. All right, question 4 should have gone better. Yes? Okay, let's check question 4. Okay, they give you an inclined plane there. They tell you there's A, there's B, there's C. They tell you this is a rough surface. This is 30 degrees. There we have block P, that is 2 kilograms. And we have block Q, that is 3 kilograms. And it's being pulled up 36.25 newtons. All right, that is all that they give you. They tell you this is parallel to the incline. That's important. They tell you there's friction and there's frictionless. And then below the diagram, they give you more information. So normally in an exam or test, that is how it's set up. They give you information at the top, and normally that information is in your diagram as well. And then whatever is written at the bottom of the diagram is not in your diagram. Okay, so make sure you read what is at the bottom. It says there's a frictional force here of 2.5 Newton. Okay. Now they immediately start asking the coefficient of friction. What did they not ask? Nee, Carlo. Say again? Yes? What did they not ask? To draw a diagram. Are you just going to ignore it? No, you are going to draw it. How many objects do we have? We have 1, 2 objects. How many diagrams are you going to draw? 2. Now, ladies and gents, I am a very verbal marker. I will lose it if you don't draw your diagrams. Literally, lose it. Do you know how Serena Williams plays tennis? Have you seen her? I'm like that. When I mark, no! Yes. So that's why I mark in the middle of the night, so I don't disturb my children. You will see my anger in my pen if you don't draw a diagram. Okay. Give me the forces acting on P, please. Okay, they say it's moving up the incline. So it's not static friction. It's kinetic friction. In which direction? Yes? Wait. Okay, for Q, really? Say again? So show me again with your hand where? Thank you. Shouldn't there be a frictional force here? No, that says frictionless. Now you're not going to leave it there. You're going to split it up into its perpendicular components, parallel and perpendicular. And then, yes.
This is not quite obvious because it said in the question, it said it was being pulled at 36.25 meters, like that constant. So in my
Does it say constant velocity?
But it's still moving at constant.
No, they say there's a constant force. But it didn't say constant velocity or constant acceleration.
And if there's a constant force, wouldn't there be a constant velocity?
No, not necessarily. It depends on the friction, it depends on the type of block, it depends on the angle, the weight, a lot of things. Okay, so constant. So I'm going to be with you in a moment. So she's referring to these words that says there's a constant force. Constant force does not mean constant velocity. It does not mean constant acceleration. It depends on the question. Yes, ma'am. No, louder. One way to think of it is?
You're pulling an object at a specific force, but the object is too heavy to move with the force of the light.
No, but it's not stationary.
It is moving.
It's moving. They say as it moves from A to B up the incline. So it's moving. It depends what type of friction there is. What weight is it if it's going to accelerate or be at a constant velocity or stationary. So constant force is not equal to anything. Constant force just means the force doesn't change to 30 and then it's 35 and then it's 40. It just means the whole time that we're looking at the scenario, it's 36.25. That's all that it means. Okay. Right, then you're going to highlight the forces that are in the same plane. Can I see who did these diagrams correctly? Okay, so the rest of you, you know where you've made your mistake? Have you corrected your mistake? Because you will get something like this in a test or an exam. So it's important that you know where you've made a mistake so that you can correct it for the future. Nia Carlo, was your diagrams correct? You have a jersey on. When you do this, there's an exothermic reaction going on. You're burning heat. You're heating yourself up. Yes. So when you get warm, you should breathe less and move less. Breathing is a respiratory action that is also an exothermic reaction. So you shouldn't go swarm, swarm. You should go. All right. First question there. Question 4.1. They ask, calculate the coefficient of friction between the surface and the 2 kilogram block. So the coefficient of friction, and if you look on the data sheet, there's a formula that gives it to you over N. Now that N refers to the normal force. Okay? And then we need the frictional force. Now the frictional force, they gave that to us as 2.5. Okay, so that there is 2.5. Then for which block specifically are they asking? For the 2 kilogram block, for P. So when they ask for the normal force, we must look at the normal force at P. So the normal force I've highlighted blue, so I'm going to look at the blue part there. And I can see there, I've only highlighted two blue things. Again, I have two conditions. The object is at rest in the vertical. So it's not going up and down like this, it's going there. Okay, so in the vertical it's at rest, and there's only two forces. Dankie. There's only two forces. So that is why this one is equal to that one. Are you with me?
Yes.
So you can't say Fn is equal to Fg. If you say that, you are wrong. It depends on the situation. In this situation, there's only two blue forces. The object is not moving up or down. So Fn is equal to Fg perpendicular. Okay, and how do we calculate Fg perpendicular again? It is Fg cos of theta. How do I calculate Fg again? It's the mass times 9.8 times the cos of theta. So that is what I'm going to do when I fill in there. Okay, so I have 2.5 divided by the mass is 2 times 9.8 times the cos of 30. And when you calculate that, wow, what did you get? .15. Is there a unit? The coefficient doesn't have any unit because it is a ratio. So it's a ratio, so it doesn't have any unit. And it should always be smaller than 1. It's always going to be 0. What. Can I see who got this right? Okay. Good. Next question. Question 4.2. They ask, calculate the size of the acceleration on block P as it moves from A to B. You can see it counts 6 marks. 6 marks tells you definitely more than one calculation. Ne? Right? Now, what did I want to say? There's 6 marks, more than one calculation. They ask for the acceleration on block P. Are you only going to look at P? No. Because P and Q are connected with each other with a rope. So if you were walking without a school bag and with a school bag, will you walk at the same speed?
Yes.
And your school bag is too light. Okay. When you're without a school bag, you are light as a feather. As soon as you put that bag on your body, you feel like, oh, there we go. And now you walk. Right? So when something is attached to something else there, it will influence the acceleration. So when they ask for the acceleration of P, you can't just look at P because it's attached to Q. And because it's attached, it will influence one another and they will have the same acceleration. Same acceleration. Alright, so that is why you should have done 2 calculations. You should have looked at block P and block Q. Can I see who did that? 2 people. Hands up. I just want to see, where are we at? How many million questions like this should we do? Hands up if you looked at both. Only 2. Out of this whole class. Say again? No. Okay, no. Alright, so we are going to look at the yellow forces. You guys remember we have extra classes on Monday, not extra classes, class on Monday. English and Afrikaans class together. So you're going to have to be wake up because they're going to speak Afrikaans and English in one class. And most probably on Wednesday. Let's see how it goes. Big. at this speed that you're doing homework and not getting it right. Praat julle Sotho met mekaar, dan praat ek Afrikaans. Maar dan moet hulle nie Sotho praat nie. Jy is in die Afrikaanse skool al van graad 1 af. As jy nie Afrikaans kan praat nie, hoe die hel is jy in graad 11? Ekskuus, ek kan nie hoor nie? Ek gaan, as julle Sotho praat, praat ek Afrikaans. And you are excluding me from the conversation. I don't know what they're saying. Yes. All right, let's